Welcome to the lecture series of PowerElectronics. In this video, I am going to discuss the design of single-phase half-bridge inverter using MATLAB. In the previous video, I have discussed the design of single-phase full-bridge inverter using MATLAB. So similarly, I would like to show you how do you design single-phase half-bridge inverter using MATLAB. So there are few steps you need to take care into consideration. First, in the foremost thing, you need to have the proper parameter definition. What are the parameter definition? We have input voltage, then switching frequency, and the time step for the simulation. Either you want to have like one cycle or two cycle or three cycle. That is what time step implies. Create the time vector. It defines the simulation period and the time vector. Next is the generating the switching signal. It is very essential that like we have two switches, we need to have the proper control of two switches. The operation of two switches will be anti-parallel in the sense both are like opposite each other. Okay, the square wave to control the switching pulses duty cycle at an alternative voltage positive and negative cycles. Okay, like the S1 that is equal to minus S2. The pulses will be in that particular fashion. In the first step, generate the output to voltage waveforms. The output to voltage waveform will be plus VDC by 2 and minus VDC by 2. Okay, then you need to decide the what could be the the frequency of output to voltage, right? Once it is done, up to 1 to 4, your code will be completed. Later, you will be plotting the results, displaying the input signal and output waveform by using the command called plot. So these are the basic like steps which are involved in design of single phase half-bridge inverter using MATLAB. Now I am going to show you how to develop the same condition in the MATLAB. First of all, I request you to open the MATLAB by double clicking the MATLAB icon. So thereafter, what you can do is go to command window, then type edit, then editor file will be appeared. I'll be showing you how about the editor file. Okay. So editor file will be looking like this. I can show you once. So as you can see, the editor file will be looking like this. So we can type the code. How many lines? If you want to occupy, you can do it. So the first step is you need to you need to comment. We are doing the simulation of single phase half bridge inverter followed by percentage. After percentage, so it becomes like a comments. Next is you can go for like a clear the previous variables, then clear the screen. Basic comments you can apply. Now parameter definition. So VDC input voltage is 100. Then frequency, the expected output frequency. Then switching frequency is 1 kilohertz or 1000 hertz. Then time period is equal to 1 forward slash f. That means 1 by f. Then TS equal to 1 by fs. Okay. Similarly, you have to define the time vector. For the two cycles only, I'm going to go for that. Starting from 0, then TS, then 2T. Correct. Next is like a switching signal for the half-bridge inverter. So you know that you have to define the switching pulses. So S1 is equal to square 2 pi f into T. So S2, you need to understand that both the operation will be negative or in a reverse manner. So S2 will be equal to minus S1. Now, output voltage can be computed by using the formula Vout is equal to VDC by 2 into S1. So this inverter is not efficient as that of full bridge inverter. So minor changes you have to take care. Now, plotting the results, you can use the figure. Later, what you can do is you can use the subplot. So actually, we have two figures. And I mean, for that purpose, two rows are required. In that first column, let me focus, and the first figure. That is the meaning of 2, 1, 1. Now you are going to go for the plot, then T, VDC star once size of T, correct? So also we can mention the color, then line width, everything you can mention accordingly. So let the graph be printed. Till that, you can put hold on. Thereafter, you'll be going for a plot function. So here the x-axis will be time. So you'll be plotting VDC into the ones size of T. Okay, at a following dimensions. Then title DC input voltage, X label and Y label can be given as per your choices. Then grid down can be done later on legend because we need to identify where it's plus VDC and minus VDC. So legend can be used. Similarly, plot the output waveforms. Let me go for the subplot 2, 1, 2. Then plot, you can use the plot function, provide the suitable title, then labeling, X labeling and Y labeling can be done. Then legend V, out. Next is displaying the waveforms. Display simulation complete input and output waveforms so that you will be getting a better understanding. So what you're supposed to do is you have to go for the run button. So once you click on the run button, you can get the waveforms. I'm going to show you how the waveforms look like. Yes, this is the waveforms. We have DC input voltage, but if you talk about output voltage, it is fluctuating. Correct, no? It varies in between plus 50 to minus 50, so that the output voltage is getting fluctuated. So this is the waveforms. As you can observe, this is the waveforms of single phase half bridge inverter. Ultimately, if you compare with the single phase full bridge converter, we have only two switches. Also, the average output voltage is less compared to single phase full bridge inverter. That is a setback. Okay, so these are the basic information about how to plot the half-bridge inverter using MATLAB. If you have any queries, you can reply. I'm going to answer back. Thank you very much for watching this video. I wish you happy learning. Have a great day. Focus more.